Hello and welcome back to the Incubator at the Bench, where we're incubating discoveries. My name's David McCulley. I'm a neonatology physician scientist and developmental biologist at the University of California in San Diego. I'm very honored to be able to host this program with Dr. Misty Good. Misty, do you want to introduce yourself and introduce our guest today?
Sure. Thank you so much, David. I'm thrilled to be here today. I'm Misty Good. I'm the Division Chief of Neonatology at UNC Chapel Hill and passionate about fostering the next generation of physician scientists. And we're just absolutely honored and delighted to have Satyan here today, who is just a brilliant mind, really shaping the future of neonatal care. He's a neonatologist, scientist, and an outstanding department chair of pediatrics at UC Davis. His career has spanned groundbreaking research, clinical innovation, academic leadership. And he's an artist for all of these amazing um, illustrations on physiology that he'll tell us when he has time to do it all. He's really made significant contributions to neonatal health and really advancing pediatric care, and all of his work continues to inspire all of us and also the next generation of neonatologists and scientists. So today we'll talk about his journey and all the exciting developments that he sees for the future of neonatal medicine and really his vision for all of us in the NICU. So Dr. Satyan, it's an honor to have you with us today. And if you don't mind introducing yourself for our listeners.
Thank you, Misty. Thank you, David. I'm a big fan of this program and also a big fan of both your research. And thank you for doing this bench to bedside podcast. Um, to introduce myself, I'm the physician in chief of the Children's Hospital at UC Davis. I'm a physician scientist. And more importantly, I'm a neonatal critical care physician and also an illustrator, as you mentioned. And I derive great pride and enjoy doing each one of these jobs. I often tell my mentees that I have 8 jobs in this, and I do have the best jobs in the world, and I really enjoy what I do. And I also truly believe that the day you don't enjoy your job is the day you should quit that job. And as I mentioned, every bit of my career and my job is something that I have immensely enjoyed, including being a physician scientist. And the program that you're running is truly inspiring. I've heard every single one of your podcasts, and there is always something to learn from every single physician scientist, especially neonatal physician scientists. And I thank you for doing this.
Thank you so much.
Feel very lucky to be able to do it. It's, I think, a really great way to be able to talk with inspirational physician scientists like you and hopefully be able to inspire people that are early in their careers, but also, inspire everyone who's on this career path. And I think it's really a great opportunity just to be able to hear, what interested you in the topics you're studying. I know you as a sort of fetal to newborn transitional physiology researcher, but also you study nitric oxide, oxygen physiology. I mean, I study CDH. I know you're interested in CDH as well, and that sort of overlaps with all those different things. If you could just sort of, for people who don't know you as well as we do, just talk a little bit about the fields you're really interested in, and maybe give a little bit of background about how you got interested in them.
Great. Let me start with the background and then I'll tell you what my areas of interest are. I never wanted to be a researcher. My idea of joining medicine was to be a clinician. And in fact, soon after finishing medical school, I went back and joined Indian Railways as a railway medical officer. It was an administrative and a clinical job. During that period, there was the Sri Lankan refugee crisis, and I was working in South India. And there would be these long trains full of refugees moving from Sri Lanka to Chennai at that time. And they would stop at my railway station, and there would be a lot of children with cholera, which was epidemic at that time, and they would present with dehydration. And there was not a lot of time to treat them, so many of them would get oral rehydration solution packets from the WHO, and to my surprise, most of them would get better. And that was when I started reading more about ORS and the simple science behind how oral rehydration works. And that's what got me interested into research. And I went back to do a residency in pediatrics and started doing research at that time. My research interests are quite varied. They vary from newborn resuscitation, which is something I feel very passionate about, having been a pediatrician and who has worked in remote areas of India. I feel the fact that simple resuscitation techniques make such a huge difference in reducing neonatal mortality. And more importantly, I've seen the long term effects of birth asphyxia and the fact that a simple, effective bag mask ventilation provided at birth can prevent such long term disabilities. Really, this is something that's really makes a difference, and I feel passionate about improving techniques of neonatal resuscitation. As part of that process, as you rightly mentioned, David, I'm really into what happens during fetal to neonatal transition and all the disorders of transition, such as transient tachypnea of newborns, surfactant deficiency, and of course, pulmonary hypertension. All these things are very important to me. And more recently, I'm looking more into the effects of asphyxia, pulmonary hypertension, and what can we do to improve not only the neurological outcomes, but also pulmonary outcomes in these children. And I often call myself a bedside to bench researcher. We often talk about bench to bedside, but I've always worked in the other way. All my ideas come from questions from fellows during rounds, and we take these questions and go back to the sheep lab and try to answer them. So I'm more of a bedside to bench researcher, and off late, a few of those ideas have come back to bedside. So often we talk about bench to bedside, but in my opinion, it's a two-way process. Ideas are generated in both areas, especially on the clinical side, and you take it to the bench and come up with solutions, and you bring it back to the bedside to do clinical trials. And that's what I've been doing for the last 3 decades.
Satyan, I'd love to dig into that a little bit more because I know you do just wonderful work on sheep. And how did you get interested in large animal work?
That's a very interesting story. I went to Buffalo to be a clinical neonatologist. I had no interest in research. And the tradition at University of Buffalo at that time, this was in 1996, was that you would spend the morning in the NICU during your interview process, and the afternoon you spend at the sheep lab because that was such an integral part of being in Buffalo. And I told my program director that I'm a vegetarian and culturally I'm against animal research and I will not go to the sheep lab. So I cut my visit short, went to Niagara Falls with my wife in the afternoon, and then went back to New York, where I was from at that time. Subsequently, when I joined the fellowship in Buffalo, I ran into a very inspiring person who you all know, Dr. Robin Steinhorn. I took my first call as a fellow with her. That's a story for another day. And I was very inspired by her clinical acumen and how she used basic research to answer questions at the bedside. This was the time when two of the most important discoveries in neonatology were taking shape, inhaled nitric oxide and also surfactant. And Buffalo was a pioneer in this area, having done initial studies in sheep using inhaled nitric oxide and a lot of studies using InfoSurf, which was produced in Buffalo. So there was a baby with severe PPHN who was born, and Robin Steinhorn and my chair at that time, Rick Moran, both of them literally wheeled a humongous tank of nitric oxide. This was industrial nitric oxide, and it had several connections to it. It was so complex, and they had to dilute it stepwise to bring it down to something like 100 parts per million. And then they would give it to babies. And there was this baby that I still remember that had brought in from a distant place, I believe it was Albany, to Buffalo, and they gave this gas to this baby, and the baby turned completely pink within seconds, and the SATs went up from 60s to 100%. And it was, that was like a mind blowing thing. And subsequently, Robin was very clever. She took me to the sheep lab, and I said that I could watch it from a distance and showed me the studies that was being done using inhaled nitric oxide in lambs with pulmonary hypertension, and then also told me that I could work with vessel rings and stay away from whole animals. And so I had a lab upstairs where I would not go to intact animals at all, And she would go down, dissect all the lungs, and bring pieces of lungs to me. And my colleague at that time, who was a lab supervisor by name Sylvia Gugino, who used to work in Professor James Russell's lab, who was a PhD physiologist. And we used to dissect these vessels out and work on them. Subsequently, one discovery led to the other, and I was looking more into oxygen toxicity. And one of the most interesting findings in the vessel bath was that any lamb that has received a lot of oxygen during with in vivo ventilation, their pulmonary arteries showed extremely high contractility with norepinephrine. This was a very paradoxical finding, and we had to really look and see why this was happening. And that got me into the sheep lab. And subsequently, have done over 1,000 animal experiments. And have come to terms with the fact that studies on these animals are really important, because whole animal physiology is something that you cannot replicate with computer-generated AI or even with small animals. And what you find on this lab saves lives. And I have come to terms with that whole concept. And we continue to do a lot of experiments to this day using whole animals, mainly sheep.
That's incredible. Do you have fellows that, like, are afraid of the sheep, or do you coax them into it and tell them about your journey, and that helps them get a little more excited?
Um, Not really. Most fellows are okay with it, mainly because so many new things have come into effect through studies in lambs. As you well know, as Paul was mentioning a couple of
Yeah.
weeks ago on the same program,
Right.
it was 1930s and 1940s when initial studies in sheep began looking into fetal physiology. And using simple plastic catheters at that time, they could instrument every single organ in sheep and look at hemodynamics and gas exchange. And that has led to very important discoveries in neonatology to this day. When you look at the textbook of neonatal resuscitation, you realize that more than half of the guidelines that we follow in resuscitation are based on animal studies, and very few are from human studies. So these large animal experiments really make a difference, and I'm a true believer. And have worked with several mentors in the sheep lab. I've worked with several mentees in the sheep lab, and it's inspiring to see mentees of my mentees continuing the sheep lab and come up with new discoveries and inventions. And that's the I feel that like they're my grandchildren. So it feels very happy to see them present at PIS and receive awards, etc.
That's incredible.
Can I want to ask you a question just about thinking about using sheep as a model, just because it's harder to have like a large number of animals to do the same experiment and do it iteratively. So, like, if you have I, I agree with the idea of having like your inspiration at the bedside. Like, you make an observation and then you want to test it in an animal model. And I think that's a great paradigm. But it must be that you then, it seems like you make these really detailed observations on a limited number of animals. How do you then, expand on it? Like, you develop a new hypothesis, you want to test that hypothesis. How do you think about doing that? Do you immediately go back to the sheep, or do you use those dissected vessels as a way to sort of test something new and maybe make a slight change and then do it again in a sheep? Or what do you think about that?
That's a great question, David. Initially, when I started my career in Buffalo, we would do exactly what you said. Robin Steinhorn was one of these pioneers who had discovered the importance of sildenafil in pulmonary hypertension. She still has a letter that she had written to Pfizer way back in 1997, asking for a few samples of sildenafil to study in sheep. This was way before anybody had thought of using it in pulmonary hypertension, and they refused because they did not want the label Viagra to be tainted by neonatal pulmonary hypertension or something totally different. And they sent us a substitute for sildenafil called as E4021, a substitute product. And we used to use it in vessel baths to come up with the optimal dose to see how it interacts with inhaled nitric oxide, etc., and then transfer the effect over into large animals. With vessel baths, we can do like 20, 30 studies at the same time using different doses. So we
Mhm.
can use those studies to come up with optimal doses for medications and then transfer it over to large animals. As you rightly pointed out, large animal studies are very expensive. A time-dated pregnant ewe costs somewhere around $1,800 to $2,000. So you need to be very careful when you plan these studies. And thankfully, I have been at two labs, one in Buffalo and one here at UC Davis. Both of them are incredibly well run and well organized, and that really helps us fine-tune our studies so that not a single tissue from these animals goes to waste.
Yeah, I think that's really an important point that research can be expensive, right? And so when you're let's say, you have a fellow that is in your lab and is really fortunate to be able to work with large animals, and then they become an early career faculty member, they may stay with you, or they may, for whatever personal reasons, et cetera, may go to another institution, for example. How do you find that they're able to launch their careers outside of somebody? It sounds like, Dr. Steinhardt gave amazing mentorship and you were able to benefit from that. And obviously, your career is absolutely just awestruck, incredible for the rest of us to watch. But if I'm listening to the podcast and I'm a NICU fellow, like, and they don't know how to get involved in large animal or start their own lab, um, in an outside institution, what advice would you give to them in that regard?
Yeah, I do agree with you that large animal research is challenging. And as many of you know, working with pregnant ewes carries the risk of Q fever. And because of that, we literally have approximately 8 to 10 labs in the country that can do perinatal research. It does limit you to where you can work if you want to continue working in sheep. But on the other hand, piglets are much more easily available. So transitioning between neonatal sheep and neonatal piglets is an option. And the research is basically learning the concepts and techniques, and you can often transfer things that you do in large animals to rodents and other models as well. But I do agree with you that it does have limitations, and that's why I have had my career only in two places, Buffalo and UC Davis. And having a sheep lab is an essential part of where I could move, and that does cause some limitations. But it also opens up new opportunities. And when you write an NIH grant, you can clearly say that you're one of the few labs in the country or in the world that can carry out such research, and that does make you unique and enhances your ability to get grants.
That's very true, and it's so nice to be able, if you're doing large animal, to be able to translate it to the clinical arena, and I think for mentees, they can really see that this work is really making a difference in how, we treat our patients.
Yeah. I agree that, for example, one of the areas that I have worked on for the last 20 years, starting with Robin, is to figure out what is the optimal FiO2 or saturation target or PaO2 in a term baby with PPHN. And it's fascinating to me that this is such a burning question in preterm infants, and we have done neoprom trials with close to 5,000 babies. But there is not a real large multicenter randomized trial in term infants trying to figure out how much oxygen we need to give. And all the data comes from sheep models. And this is an area where I was truly inspired by my mentors, uh, Robin, Jim Russell, and I actually consider my lab supervisor, Miss Sylvia Gugino, as my third mentor because she taught me many of the techniques I know and many new ideas came from her. And during rounds, we would argue as to how much oxygen each baby should be on, especially diaphragmatic hernias, because that's an area where the pediatric surgeons used to want a lot of oxygen, and we neonatologists wanted to use less oxygen. And trying to figure out what we should use was a burning question. And so we started doing studies both in vessel baths and also in intact lamps to figure out what oxygen concentration and what saturation range results in the lowest pulmonary vascular resistance with the least amount of oxygen toxicity. And a surprising finding at that time was that when you maintain saturations between 90 and 97%, the pulmonary vascular resistance would be at the lowest, But on the other hand, when you went up to using much higher concentrations of oxygen, not only would the pulmonary vascular resistance go up, but it would also lead to inhibition of the effectiveness of inhaled nitric oxide. And that led to more of the current guidelines of using oxygen concentration in the low 90s when we manage babies with PPHN. So there are answers that you can come up with using these animal models that do make a difference in clinical guidelines. And that's really the whole point of doing large animal research.
Yeah, it's
One
fantastic.
of one of the things I find really fascinating about your work and by the people that you've mentored who have also succeeded, it seems like the key is just really detailed observations. Like it's obvious, like when you have a patient, you are really attuned to like just very subtle changes and kind of having an open mind. Like you don't just say, well, it would be obvious that if you just kept the sats as high as possible, that they should have the best outcome. You didn't say like, oh, that should just be a given and then identified that the slightly lower oxygen saturation might actually be optimal. How did you come to recognize or maybe I don't know, do you recognize that those observations are so key? And how do you inspire your trainees to, you know, keep an open mind and be really attuned to those subtle observations to ask the research questions we're interested in?
Yeah. So mentees are really important. I often equate mentees to children. I have 3 children and I have a lovely family. My wife is a physician scientist as well. She's an adult cardiologist who investigates methamphetamine-induced cardiac toxicity among veterans. She works at the Veterans Affairs here. She's an MD PhD, by the way, and I learn a lot from her. And I learn more pediatrics, not from the Nelson's textbook, but from my own children by working with them, by learning from them. And similarly, mentees are the same as children. There's no difference at all. And I also mentioned that just like the way you love your children throughout your life and you defend them, whether they do right or wrong, same thing applies to mentees. You got to stand up for them and support them in every single situation. So, mentees being young are very curious people and they come up with really interesting questions and they often question you. And it's really important as a mentor to take a step back and give importance to that question and nurture that idea. For many fellows who join a new place, it's often overwhelming to figure out who to pick as a mentor and what kind of research you do. And many of these young fellows come with really new ideas. So, for success, in my opinion, it's really important to combine the idea that you feel passionate about with whatever resources are currently available in your mentor's lab and try to come up with a ideal combo of both of these things for new research. And that's the right way to go. And I was really interested in resuscitation and oxygen, and Robin's lab was very much into looking into oxygen toxicity at that time. So it really worked out well. And many of these studies came through. So going back to your question specifically, David, uh, there are questions that come from many people during rounds, especially sign outs are really fascinating times. When you stand at the bedside and sign out, the nurses ask you some questions, and this is where the ideas come from. And then you need to have a really good group of lab folks who can sit and dissect that question and try to figure out what can we really answer using and doing an experiment, and then try to devise an experiment to answer these questions. So the oxygen is a classic example. More recently, I have spent a lot of time looking into resuscitation, the optimal oxygen concentration during resuscitation, and more recently into epinephrine. Just to give you an idea of what epinephrine, we all use epinephrine, and we were at a resuscitation of a really sick term baby who basically didn't have a heart rate. And I gave epinephrine, and then I asked for a flush, and the nurse gave me a syringe full of flush. I took the whole flush and pushed it through, and then the baby came back and had a return of spontaneous circulation. And then I realized that I had pushed 5 cc of flush. Whatever the nurse gave me, I wasn't even thinking. I was very tense and I pushed the whole thing. And that got me into thinking the NRP book at that time recommended only zero 0.5 cc to a cc of flush. And is this really enough? And nobody really thinks of it because you literally push whatever the nurse gives you at that time. So Bobby Matthew was my colleague at the time. He and I took a lamb that was already dead, took a bunch of Omnipaque, went to the X-ray machine, and injected half a cc of Omnipaque into the low umbilical vein catheter. And we realized that the dye did not go beyond the portal venous system. And then we injected a full 3 to 5 ml, and then that really disseminated all over the lamb during chest compressions. And that led to a study done by Deepika Sankaran, one of my colleagues right now, using a higher volume of flush. And there was no clinical study, and the NLP textbook decided to change their guidelines to add 3 ml flush based on a single X-ray and a single lamp study. So that's the what I call it the power of animal-based research. You can do things that you can't really do at the bedside, but you can come up with very meaningful answers.
That's, like, such an interesting approach to think about. You do one thing in an animal and just easily translate it, not just to the bedside, but in the entire NRP book and guidelines. It's incredibly impressive. And I'm just in awe. I wanted to shift. You've done so much in research, and some of our listeners, are like mid-career or thinking about their next move in terms of leadership roles. Can you talk about your leadership roles across your career journey and when you decided you wanted to be a department chair, for example, and I don't know, just steps along the way?
Um, my career is not a very typical one, partly because I'm an immigrant and I came here on a J1 visa. So, as many of you know, I did my fellowship in Buffalo, and subsequently I had to do a waiver job. So I moved to Pueblo, Colorado, to work as a pediatrician. Those 3 years of this waiver job were eye-opening to me for many reasons. One, I realized that whatever research we do makes a difference in patients' lives. I was the only neonatologist in a small town with close to 6,000 deliveries, and and we were in close proximity to Denver. John Kinsella and Steve Abman, who were at Denver at that time, were very nurturing. Every patient that I sent to them, they would call back with detailed feedback because they knew I was a neonatologist, and they invited me to come around with them, and it was very supportive. But I also learned that um, being a medicine has several aspects to it. It's not just science. There is also a issue of providing the optimal clinical care. Then there is the issue of teaching, and then there is obviously the issue of administration and finances. So I really got interested in all aspects of this. And then subsequently, when I finished my 3 years with the waiver job, I was starting to look for jobs again. And Dr. Rita Ryan, who was the chief at Buffalo at that time, was kind enough to recruit me back to an academic position. Those years were a bit hard, but thankfully, Robin again came to my rescue and gave me a subcontract on her NIH grant that I could continue working in the sheep lab. It took me a while to get a green card, and for that reason, I could not really apply for a K grant. So I had to make do with other grants, apply for neonatal resuscitation program grants, etc. So the first lesson I learned was that write papers first and don't focus on grants. Everybody wants to get a grant right away, and without writing a few papers, you really can't move ahead with that. And so have a few papers in hand on the topic that you really feel passionate about so that your CV looks strong, and then start applying for grants. The second, the value of a grant or the amount of money you get does not matter. I applied for a bunch of grants, couldn't get any of them. And my first grant was the Neonatal Resuscitation Program grant from the American Academy of Pediatrics. And I remember to this day when Dr. Marilyn Escobedo, the former chief at Oklahoma, she called me by phone to my desk in Buffalo and said that I had received a $10,000 grant from NRP, and that was the best day of my life. You know, if the first grant is like your first love, it really makes such a big difference. And I was very happy to get that grant was obviously on oxygen usage during resuscitation. and subsequently I became a member of the NRP. Um, After that, after a few years of being in Buffalo, Rita Ryan decided to take a job as a chair. And one day when we were driving together to Toronto for a meeting, she suggested that I take over as the interim chief from her. And I was very surprised by her choice because I was a lab rat. I really did not know much about administration. But I always had an interest in coding and finances. So subsequently, I took over the administrative position. The best part of being an administrator is that you can nurture other careers. I was a chief in Buffalo for 7 years, and the thing that I'm most proud of is not the fact that financially we did really well during that time, but I'm more proud of the fact that I could mentor a few fellows, especially Jayashree Nair, Praveen Chandrasekharan, Munmun Rawat, Deepika Sankaran, Payam Valley. These were all fellows in Buffalo who did phenomenally well that I had a chance to mentor them. And as an administrator, providing them with adequate resources and time and ideas and support really makes a difference. So with everything that's happening at NIH now, the role of a chair or a chief really, really matters. There are studies to show that the well-being of faculty is primarily influenced by the support they receive from their immediate supervisor. In fact, that's the chief or the chair for that matter. And having an appropriate program that nurtures you during the initial years of your career makes such a difference in the long run. And I think every physician leader in this country should focus on nurturing because that's the thing that determines your legacy, not how well the unit was run or anything else. Those are important as well, but your mentees and the faculty that you nurture really determines your legacy. And making sure that they function well and become productive physician scientists is the primary goal of every single administrator.
I agree with you. I think, for my own career personally, the division chief and department chair, which was Gary Silverman and David Perlmutter at the time when I was at the University of Pittsburgh. I mean, they were instrumental in just continuing to support me, not push too hard, but really just fostering me along the way, making sure I stayed on track and really providing that not just financial support, but emotional support, which I think is really needed in this field because it is a difficult career path, but it's so worth it and so rewarding. And sounds like, I mean, I see why. I mean, I know what you mean about being the division chief. It's really the best part of it is being able to nurture careers at the, not just fellowship level, but even early career and even mid-career faculty level as well.
Yeah, you're a classic example, mentee. You're passing it forward. I see your mentees present. As you know, Jen Canvasser is a colleague of mine here in Davis, and all the research that you do in NIC, all the research that David does, you both are passing it forward to your own mentees, and that's the whole purpose of doing research.
Definitely trying.
Yeah, I agree. I find this to be one of the most inspiring things. I just love being able to recognize your former, mentee, Satyan, because they all have the same sort of characteristics, like, they all were inspired to make really detailed observations. They're all, open-minded and, really thoughtful, but so focused too. It's just really incredible. You can see how much, your kind of personality, but also your, just passion for your research really rubbed off on them and inspired them. So, I mean, it's hard to think about how to really try to mimic that, but I agree being able to, have a role in mentoring people at an early stage of their career is just it is really powerful. Um, one of the other things I was wondering about is just like, it seems like your work is definitely very focused on, neonatology and oxygen and mechanisms of neonatal transition. But I wondered, just like thinking broadly about, pediatric research more generally and opportunities for collaboration with people with outside of pediatrics. How do you think about that?
Yeah, in this day and age, collaboration is key. Ideas come from discussion with multiple people, and it's difficult to develop expertise in every single area that you want to nurture into. My lab is really good with whole animal physiology work, and we can put catheters wherever you want and figure out hemodynamics. But I've always relied on someone else to help me with analyzing tissues, looking for mechanisms for oxygen toxicity and things like that. So collaboration is key, and I often tell my mentees that they should develop a complex or a comprehensive mentoring team with scientists. It's always really important to have a few PhD scientists as your mentors, because we as scientists are very focused on clinical care, patient outcomes, even in basic research. But PhD researchers come with a much more broader view, and they're really helpful. I was lucky to be mentored by a physician and a scientist, and that really enhanced my ability to do research. And so I think that's one key area that I would strongly recommend all my mentees to have mentors who are primarily researchers. I have three mentees with K Awards right now. Dr. Heather Siefkes does work on CCHD screening using pulse oximetry, and she has a phenomenal engineer as one of her mentors, and that really helps us use AI and uh, use AI technology to enhance CCHD screening. My other two mentees, as I mentioned, are Deepika Sankar and Michelle Lim, who is a pediatric intensivist. And Michelle is into the effects of ARDS in pregnancy and how it impacts fetal care. I did not know much about ARDS, but we came up with a complex animal model. And her mentoring committee includes adult critical care physicians and a maternal fetal medicine physician and basic scientists. So having a comprehensive mentoring team is really important. It's good that if your mentors don't agree with each other, because that's where new ideas come from. So when the mentors fight, the mentees win. So having robust discussions among mentors on areas of disagreement will really enhance the research proposal and help a mentee.
That's fantastic. I was wondering, since you talked about AI, I was wondering if you could talk about your thoughts about AI, specifically in the NICU or even in pediatric critical care, and how you see that playing out at the bedside.
Yeah. AI is going to change our lives. It's already changing our lives, and it's going to do that further. That's one plug for neonatal critical care, because no matter what AI can do, it can't come and intubate a 500 gram in the delivery room. So our jobs are safe, and I tell all my residents, pick a job that can't be stolen by AI, and neonatal critical care is one of them. So this is one of my slides that I show residents, trying to inspire them to join neonatology as a fellowship. So AI will change our things in many ways. I'm hoping that we need to evolve along with AI to be able to utilize it better. This is something like internet. I mean, I trained at a time when there was no internet. I still remember the day when a new Mac computer landed up in the fellow's office, a gift from Robin Steinman, of course, with internet availability and ability to look up Medline on the computer was like a big deal to us at that time. And things have evolved now, and we assume that what we see on our iPhone and search is a given thing. But similarly, AI will change a lot for us. So one, it's important to choose a career where AI cannot take over the job, but can be an adjunct and help you with the job. And how it will shape neonatal critical care is really unclear to me at this time. But I think what we will eventually, both in the diagnostic ability and also in the therapeutic choice arena, I think AI will completely transform us. There is so much of data that we accumulate in the NICU that we really don't utilize. So I think AI gadgets will come to place that take into account every single waveform of an arterial wave, heart rate variability, and all these things, and try to come up with a simpler diagnosis for us and alert us that physiologically something is not going well in this child, and we can intervene more appropriately. Also, there will be algorithms that will tell us if the echocardiogram shows this and if this is what is happening, don't use norepinephrine, use epinephrine, or things like that. I think it will really shape us. All the Harriet Lane handbooks are gone, and instead we'll be replaced with AI gadgets, which take data from the patient and tell us what the algorithm is. And the and I think we need to evolve. For example, our board exams are so heavily based on memory right now. I think that is gradually changing into higher order thinking. And similarly, we need to not know simple facts. We need to know some basic facts, of course, but beyond that, trying to use patient information, adapting to the AI technology, and using both as an adjunct to come up with optimal therapeutic strategy will be the future for us. And it will be exciting. And I hope I will still continue to work in the NICU to enjoy the benefits of AI.
That's awesome. I was gonna ask you, because you mentioned, talking to, early career folks or residents about, going into neonatology in particular. There was, match day, was, a few weeks ago now. I was just gonna ask you, just in your view as a department chair, how you view neonatology shifting actually as a field. And, I know you wrote a paper about, thinking about neonatal critical care as its own, as its own residency or potentially its own department. I was just wondering if you could enlighten us with your thoughts on that. Share with the listener.
Yeah, let me take a step back and talk about administration in unitology as well. Why is it that the three of us being physician scientists, well, how come we have RO1s looking into genetics of diaphragmatic hernia, pathophysiology of neck, and oxygen toxicity as our research for NIH? Why are we not doing research looking into the optimal well-being of a neonatologist? How come there is no randomized trial looking into what is the length of a night shift? Should it be 16-hour shift or should it be a 24-hour shift? How come we are not doing research in those areas? I strongly feel that these areas that are important to neonatal care are as important to neonatology and should be funded by NIH as any other aspect of research. Recently, we are looking into Ryan McAdams is doing a lot of research on fatigue, and those things are really important too, and those things should be funded by NIH as well, and they're really important for our future. Similarly, financial compensation. I know money is not important. Money doesn't bring you happiness, but lack of money can bring you sadness. So it's good to have optimal compensation, and the future of neonatology is really at a crux, especially academic neonatology recently. I'm fortunate to be a consultant on the Women in Neonatology group, the WIN group. Clara Song, who is our current fearless leader of the Society for Neonatal Perinatal Medicine, has been instrumental in leading this effort along with several colleagues. I'm really happy with the projects that WIN has taken on, including sustainability projects in neonatology. And we need some change to sustain academic neonatology moving forward. So, what do I like to see in my, uh, as you all realize, pediatrics and neonatology are becoming increasingly female-dominated fields. So I believe 73.6% of incoming fellows this year are female. This is bringing about a welcome change in that we are viewing work hours and flexibility from a very different perspective in neonatology at this time. Gone are the days when I could walk into the NICU, round with my fellows, and then go to my sheep lab and study, go there, and then come back for sign out at 4 o'clock. Those days are gone. Now, when you walk into the unit, you can barely get your notes done when you leave the unit at 5 p.m. So the role of an attending physician in an academic neonatal unit has evolved so much, and so has and burnout has increased quite a bit because of that reason. So two things need to happen in departments of pediatrics for us to survive. One is fairness. Every single physician should have the same number of work hours, whatever your specialty is. And these work hours should take hazard hours, especially on nights and weekends, into balance. So I truly believe that all physicians should work approximately 40 hours a week for, say, 45 weeks, and then have 20% time for uh, things that they need to do, like administration and teaching, etc. So this, in my opinion, comes to a calculation of around 1650 hours of clinical work every year. And you need to have a very transparent model as to how you go down from there. If you have an NIH grant, if you have a program director, etc., and have a mathematical formula that's totally transparent and fair. And that needs to happen across all departments, all divisions also. Pediatrics is a very challenging department. More recently, I have taken on as the executive associate dean at the School of Medicine here, and also my dean has allowed me to look into composition plans in different departments as a co-chair of a funds flow committee. And what I'm realizing is that there is no other academic department in the School of Medicine with such a varied work review productivity benchmarks as pediatrics. In pediatrics, we range from fields where the productivity is less than 2,000 work RVUs to fields like neonatology, where the productivity expected is over 10,000 RVUs. This fivefold difference doesn't exist in any other department. And that has led to neonatology being the source of revenue to run a department. And I'm a department chair now, and I totally realize the importance of neonatal revenue to run the department. But there has to be a balance here. And the balance I'm seeking is equal work hours, taking into account hazard work hours across all divisions within the department. And the fact that adequate resources and flexibility needs to be provided, especially for young female physicians. If you don't nurture a female physician during the first 5 to 10 years of her career, you're losing out on a remarkable physician scientist, you're losing out on a remarkable clinician educator. So providing them with fairness and flexibility is really, really important. And that's what we need to provide. If we can't get a good deal that way from a department of pediatrics, I think we should start looking into a separate residency for neonatology and a separate department for neonatal critical care.
How is that viewed amongst other department chairs? Because I know you're heavily involved in AMSPAC.
Uh, I better not answer that question. So, no, it has actually gone well. Th- 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 Somebody told me once that being a division chief in pediatrics is the last sane job that you can have. Once you become a chair, it's basically insanity because you're trying to balance these differing fields within a department. And you need to keep your faculty happy, you need to keep your residents and trainees happy, plus you're answerable to your CEO on one side and the dean on the other side. So it's a very complex job, and it's a very difficult job as well. And every single chair that I've met wants to bring in fairness, and they want to do the best for everybody. And it's not that neonatology is demanding a separate deal. We just want to be treated similar to others, right? I mean, we are not asking for any special deals within neonatology. We just want to invest the equal amount of time. And that's where the concept of hours per year comes from. Um, there was a study done 15 years ago which showed that the faculty who work in pediatric emergency medicine work on an average 1,000 hours per year less than faculty who work in neonatal perinatal medicine. It shouldn't be that way. Everybody should work equal hours. And I think that's something that we need to champion and bring about. And there are lots of efforts being done by AMSTAC, the chairs organization, to do surveys and bring out work hour equity. And I think all the chairs are very much in favor of doing it. The chairs are one thing. We need to maintain the pediatric workforce. And to do that, we need to bring fairness to the field. Otherwise, we will face a lot of imbalance between work and life. So that cannot happen. So I just stepped down being the chair of the clinical care committee at AMSTAC, and I find my colleagues to be very receptive to new ideas on what we can do to enhance the workforce. And they're all open to having fairness and transparency. So I think this is an open idea that will be embraced by all the chairs.
It's great to hear you focusing. I think those two words are the key: openness and transparency. Because I think, that is a sense of an approach that I think will allow people to see the power of collaboration and how it can be effective. And if it isn't working, like, we'll shift and have a different approach. But I think it's the same characteristics that have allowed you to be a really successful researcher. Just the idea of the power of observation, the idea of keeping a very open mind and trying new things, and the power of mentorship. that I think are translating obviously from your success as a physician scientist investigator into this really important leadership role that, I mean, I think we all find inspiring and I think has made you one of the leading voices in our field. So it's amazing that you are doing this work. If we, I don't know if you want to respond to that, but I want to
No,
transition.
I really appreciate your remark, David. And I see no difference between basic research and administration. And as I told you at the WSPR meeting, um, I see oxygen toxicity to be the same as burnout.
Yeah.
And just like using optimal FiO2 is important for management, using optimal clinical FTE is important for clinical welfare. You can't use 100% oxygen. That doesn't lead to good outcomes. You can make a person work extra hours, and that doesn't really lead to a good outcome. The key, of course, is improving Medicaid. For example, if you have anemia and if you have 5 grams of hemoglobin in your blood, no amount of oxygen will help you increase oxygen delivery to the tissues. Similarly, if Medicaid is reimbursing at a very low rate compared to other fields, other insurances such as Medicare, no matter how much a pediatrician works, it will not improve compensation. And so I find so much of similarity between basic science and administration, and there has to be national level changes to enhance compensation for pediatricians that are direly needed at this time.
Just seeing those analogies is just so helpful because I mean, we can all appreciate that clinical scenario and how you can apply it to something that's entirely different, but is really identical, really same concept. The other thing that is really inspiring about you is just how you can explain these really complicated concepts in a clear way. And I think this helps us transition to just one last thing that I think will be fun to talk about, which is your illustrations. I think that those are such a powerful tool for explaining these really complicated concepts to trainees, even to families. Like we're having a difficult time trying to explain like why we're using this medication or what's going on in the baby in this case. How did you get inspired to just begin working on those illustrations? And how, as Misty said earlier, how do you find the time to do them?
Um, I wanted to be a comics writer. When I grew up, we didn't
Wow,
have
I did not know
video
that.
games, so I really wanted to be a comics writer. I love comics, all types, and I start my day reading my daily strip in the newspaper of comics. So, and of course, my parents really wanted me to become a physician, so I went into medical school, and I have drawn illustrations throughout, like anatomy illustrations, etc. I had no idea that I could use illustrations in publications. So there was a day when, of course, Robin was asked me to write a review article for clinics in perinatology. This was way back in 1999, and then I had literally a paper towel on which I had drawn a fetal pulmonary artery with really thick musculature, big endothelial cells, and then a neonatal pulmonary artery with much more vasodilation, thin endothelial cells. It was on a paper towel, literally a paper towel. And then she saw it and she really liked it. And she took the paper towel and gave it to her husband, David Steinhorn, who scanned it and created a figure. And that was my first published figure in a paper, Clinics in Perinatology. I didn't even think of it much. And then 3 years later, when I was doing my waiver job in Pueblo, Colorado, a nurse came to me and showed me her nursing textbook of it's called Neonatal Physiology for Nurses. It's written by Dr. Susan Blackburn. So she showed me in that book, they had the same figure from my paper in the textbook. And I was like, wow, this is something I really need to pursue. And subsequently, I got into using Adobe Illustrator and I draw my figures on weekends. I find that this job that I do is fairly stressful. So I find drawing figures as a way to relieve my stress. So my weekend is spent on drawing. I draw pictures on Saturday, and if it is something that I don't run into copyright issues, I post them on X or Twitter or one of the social media on Sunday. And that has been something that I do regularly. I'm also a very early morning person, so I wake up at around 4 a.m. and then uh, go to a gym with my laptop, which is a really bad thing to do, but I sit with my laptop on a bike and then try to come up with new talks and new ideas between 5 and 6 a.m. That's my most productive time early in the morning. And every art and science go very well together. We have lots of neonatologists who are phenomenal musicians, who are phenomenal illustrators, artists, and they can easily bring about their art into medicine on a daily basis. And I think doing that will bring you more joy and more job satisfaction.
That's fantastic. I just can't even believe all of the things that you've told us and your journey today. And I know we've taken so much of your time, but we're really grateful to have you on the At the Bench podcast today. And Satyan, your insights into neonatal care, research, leadership are truly inspiring for all of us. And we're grateful for all the work that you do to shape the future of neonatology and pediatrics. It's been a real privilege to have you on the podcast. And I know our listeners will learn a lot from our conversation. So I just wanted to say thank you and express our gratitude from the bottom of our hearts of sharing your experience with us today.
Totally agree.
Thank you, Misty and David. I'm a true fan of this podcast, and you have no idea how many people listen to this podcast and get inspired. And I've had residents come to me and say that they listened to one of your podcasts and they thought of going into neonatology. What more do you want, right? Inspiring somebody is what we are here for. And I thank both of you, and also Daphne and Ben for initiating this Incubator podcast. It's making a difference. And I thank all of you for promoting science, especially at this time.
Thank you so much.
Thank
Thank you
you.
so much, Satyan.
All
Have a
right.
great day.
Y'all for listening. Take care. And we'll see you next time on At the Bench.